Hi there, this is Professor Eckhouse, and I'm going to talk about circles and irregular figures. So let's start by talking about some properties of circles. So if this picture shows the radius and the diameter. So as you can see, the radius is the distance from the edge of the circle to the center. And it doesn't matter where you draw it. You can draw it anywhere, here, 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 any of these places. Those are all radii. Okay, so it does not matter where. It's just the distance from the outside to the center. The diameter is twice that. So it's the distance from one side to the other through the center. So the formula, the distance across the circle through the center for diameter, is that it equals 2 times r. Make sure you have these all in your notes. The circumference is the distance around the circle. So where is that? Well, that is as if you were an ant walking around the circle. Okay, how far would you go if you walked around the circle? That's circumference. So it's perimeter, a special word for perimeter, around a circle. All right, so circumference is 2 pi times r, but since d is 2 times r, then you can also say pi d, because 2r is d. All right, so the area is the space that the circle takes up, like any area, and that is pi r squared. So we approximate pi with 3.14 or 22 over 7, depending on whether the radius is given as a decimal or a fraction. All right, so our book does not assume that everybody has a calculator that has a pi button on it, so it just uses 3.14, and it does make a difference. So just use one of those numbers instead of your pi button. All right, so what kind of units will radius and diameter use? Well, they are going to use length. So that is going to be things like centimeters, inches, feet, meters, yards. What kind of units will area use? Well, of course, this is an area, right? So just like any area, it can be centimeters squared, inches squared, feet squared, meters squared, yards squared, and so on. Both of them are and so on. Does pi have units? No, it's just a number. No units. All right, so a circular dance floor has a radius of 25 feet. Find the circumference and the area. All right, so the radius is going to be from the center to the edge. That's r, and it is 25. So we are looking for the circumference. So that's the area around, right? I'm sorry, the distance around, the distance around the outside, like as if you were an ant walking. And the area is going to be the surface area, this whole space in here, right? So there's a big difference. So make sure you've got the difference between circumference and area. All right, so circumference is 2 pi times r. Since we're given r, that's the one I'm going to use, because remember there's another one, equals pi times d, right? But we're not given diameter, so might as well just use this one. All right, so 2 times 3.14 times r is 25, and that is going to give me 157 feet. So remember, that's a distance, so it's feet, not feet squared. All right, area is going to be pi times r squared. So that is 3.14 times 25, that's the r squared. And you're going to get 1,962.5 feet, and that is squared. All right, let's try another one. A circle has a radius of 5.4 inches. Do the same thing, find the area and the circumference. Do pause the video and try this one. So I usually do circumference first, so that's what I'm going to do. So I've got 2 pi r, so that's 2 times 3.14 times r, which in this case is 5.4. So r equals 5.4 inches. So 5.4, and that is going to give me 33.912, and we're supposed to go to the nearest hundredth. So it's going to be, think about what this is going to round to. The hundredth is that one right there. So think about what the 2 is going to do to it. and it's not going to round it up, so it stays 33.91, and it's a length, it's a perimeter circumference, so it's just inches. All right, area is going to be pi r squared, so 3.14 times r is 5.4, and we're going to square it. So we get 91.5624, which is equal to, which is the hundredths place, that one right there. What's the 2 going to do to it? It's not going to round it up. So we get 91.56, and what is the unit? That is inches squared, because it's area. All right, so what if we are given the diameter? Remember that D equals 2, whoa, I said D and I wrote 2. D equals 2R. So what does R equal? Divide both sides by 2. And R equals D over 2. D over 2. Or you can say that as 1/2 D. Either one. All right, so a circular saw in a sawmill. This is a sawmill that's down the road from me. It's one of the oldest water-run sawmills in the country, and it actually runs a couple times a year. It's very cool. But the circular saw, in this my made-up case, it looks like about 5 feet, so that's what I said, has a diameter of 5 feet. What is the circumference of the saw, and what is the area? We're going to round to the tenths place this time. Okay, so the diameter is going to be, here's the center, but the diameter goes all the way across. So D equals 5 feet. And we need R for the area. So let's go ahead and find it. R is going to be 1/2 of D. So that's 1/2 of 5, which is 2.5 feet. So that's halfway across, right? That's 2.5 feet. That's R. All right, so let's find our things. So the circumference is 2 pi r, or you could just say pi times d, right? Start with the d. And we've got 3.14 times 5 feet. So we get 15.7 feet. So that's going to be the circumference. Then the area is going to be pi r squared. So this is why we had to divide it in half, because we have to use the r here. 3.14 times r squared, 2.5 squared. Now, I just want to show you something. I'm going to back up here. 2.5 feet squared. Where's the square feet coming from? Well, right here. It's being squared, right? So that's where it comes from. So we get 19.625 square feet, or feet squared. We're supposed to go to the tenths place. So that's the 6 right there. So that means this is going to be approximately 19.6 square feet. That's the area. Okay, example 4. A circular spa has a diameter of 12 feet. Using 3.14, approximate its circumference and its area rounded to the nearest tenth. All right, so let's see, where do we want to put all of this? So we've got a spa has a diameter of 12 feet. So that's all the way across. So let's go ahead and find the radius, because we're going to need it. So the radius is 1/2 the diameter. That's 1/2 of 12. So that is 6. All right, so the circumference is 2 pi r, or you can just say pi times d. So that's 3.14 times 12. So the circumference is 15.7 feet. And I'm going to get rid of this because it was just kind of a random thing that I had. Delete. Okay. For something else. All right, so 15.7 feet is the circumference around. All right, so now let's find the area. The area is pi r squared. So we get 3.14 times r. So this is where we had to divide the diameter in half so that we can use it for this. Oh, Oh gosh, I was looking at the wrong one. Those were the answers that were over there. That was not 15.7. Goodness. Okay, we're going to fix this. All right, so we get, this one was 30. Those were the answers. 37.7 feet is what you should get when you multiply 3.14 times 12. I should have caught that. Sorry. All right, so moving on. I was just looking at the wrong one. And so we get 3.14 times 6 squared is 113.04, and that's feet squared, but it is not rounded to the tenths place. So this needs to be 113.0, if you're going to be exact, to the tenths place, feet squared. All right, so moving on to example 5. Find the diameter of a circle with a circumference of 37.68. Okay, so now we have just been given that the circumference, that's the distance around C, is 37.68 feet. So we're trying to find the diameter. That's this part all the way across. That's what we don't know. So I'm going to use the formula C equals pi d, because we're not being asked about the radius, and we're not given the radius, but we're asked about the diameter. All right, so we're looking for d. So let's rearrange this so we solve for d. I'll just come down here. Let's divide both sides by pi. And we get that d equals the circumference divided by pi. All right, so our circumference given is 37.68 feet, and pi is 3.14. Put that in your calculator. 3.14 doesn't have a unit, so that it stays feet, and you'll find that it is 12, exactly 12 feet. All right, so that is the diameter. So across here is 12 feet to give us a circumference of that. So make sure your answer makes sense. Okay, so that's circles. So try another one similar to that and see what you can do. All right, so again, we're finding the diameter of a circle with a circumference of 94.6. So why not just start where we left off last time? D equals the circumference over pi. So we are looking for the diameter. We are given that the circumference around the whole thing is 94.2. And that's C. All right, so 94.2 centimeters over 3.14, no units. And that should give you 30, and the unit then is centimeters. And that is the diameter. So the distance across is 30 centimeters. Okay, so now we're going to talk about the area of irregular shapes, something like this. So here's what we do. We break the shape up into pieces that you know how to do, and then you add them together. When corners look like right angles, assume they are in these problems. All right, so first I want to take a look at this problem, this picture, and I want to fill in the gaps of things I don't know. Because what if you were asked the perimeter of this thing? There are two pieces missing, this one and this one. So how could you find this one? Well, if this equals 3 and this whole side equals 8, then what is this? Well, if everything is a right angle, we can assume that this is also 3. So that means this side up here above it is 5. So think about that for a moment. Okay, so then what is this side? All right, so let's break this up and say, well, if this here is 5 and this is, oh, no, that doesn't matter. Sorry, I got myself all confused. Hang on, let me erase. All right, now we're trying to find this side. I already did that one. This side. All right, so if this right here is 2, and this we know is 3, and this is 3, and this is 10, what can we use, which parts of that could we use to find the part I highlighted in yellow? Well, we're just going to use the 10 and the 2. The 10 and the 2. Because if this was broken in half in parts here, we would have 10 here and 2 here. That means this must be 8. So you've really got to think these through. These are puzzles, basically. All right, so now we have all the parts that we need. So you can break this up however you want at this point. We are just going to turn it into 2 rectangles. So what is the area of this rectangle? Well, area is length times width. So that is just 2 times 5. This one times this one. All right, so what about the area of this one here? Well, we've got area equals length times width again, so the length of this big thing is 10, and the height or width is 3. So we've got 10 times 3 is 30. So this one is 10, and the other one is 30. So what is the total? The total is going to be 10 plus 30, which is 40. And there's no units, but it would be 40 square units because it's the area. If you were asked the perimeter, you would just add all those up. So let me erase some of this. You would add up every single number around the outside. So you would say 10 plus 3 plus 8 plus 5 plus 2 plus 8. And that would give you the perimeter. All right, so you try another one similar to that. All right, first let's find, I guess, this one here. All right, so if the total height is 8 and this is 4, that means that this is 4, then this here must be 4. Right, so I'm going to erase some of that. All right, the other way. So if, let's break this up and think about this side right here. All right, so this is 11, that's all the way across, and this is 3. So then what is this? So 11 minus 3 is 8, so that must be 8. All right, I'm going to erase some of this mess. There we go, we have everything all labeled. All right, so if you were asked perimeter, you would just add them all up, like an ant walking around the whole thing. But they're asking us the area. So there's 2 ways to break this up. You could break it up into those 2, or you could break it up into those 2. It does not matter which one you do. I'll do this one because I did it the other way the other time. So what is the area of this in here? Well, it's going to be the width times the height, so that's 3 times 8 equals 24. Then what is the area of this in here going to be? So let me highlight this for you so you can see exactly what I mean. This shape, and then we've got this one in here. So what is that one going to be? Well, that one is going to be the width, which is 8, times the height, which is 4. So that's 32. So the total of this is going to be 24 plus 32, which is 56. That's the area. So it would be units squared, whatever the units are, square units. All right, find the area of this. So again, just break it up into things you know. So I'm going to do this. I'm going to say, oh, I've got like a triangle hanging off the edge there. And I know that it's 5 feet this way. So that's the base. So what is the height? Well, the whole height is 18. Minus that would give me the height of the triangle. So that's 11 feet right there. 11 feet. All right, so what is the area of the triangle? Area, and I'll use that little symbol for triangle. Area of the triangle. And that is going to be 1/2 base times height. The base is 5, the height is 11, so 1/2, it's just an upside down triangle, so don't let that fool you. 5 times 11. And that is going to be, the area of this is going to be 27.5 square feet, right? Because it's area. All right, so now what we've got left, so that was the triangle. And now we just need to find the area of this squarish looking thing, which I don't think is a square. All right, so that is going to be the area of the rectangle is going to be length times width, which is 18 times 19. And that is 342, I believe. And again, that is square feet. And I'm going to double check because I don't trust my writing. No? Yeah, that's right. Okay, so now the area of the whole thing, total area, is going to be the area of the triangle plus the area of the rectangle, and that gives me 27.5 feet squared plus 342 square feet. All right, so I get, those are going to add together. I need to look at my notes. 369.5 square feet. That's the area of the whole thing. Okay, a high school track is shaped like a rectangle with a semicircle at each end. The rectangle has a length of 100 meters and a width of 70. So I'm going to break this up into the rectangle and the semicircle. So we have, I don't know exactly where it breaks here, but somewhere in there. So we've got a rectangle and a semicircle stuck on the end. So this is 100 and this is 70. So the area of the rectangle is pretty straightforward. That's just going to be 100 times 70, which is 7,000. Now what are we going to do about those two semicircles? Do we want to find the area of one semicircle and the area of the other semicircle? And they're not supposed to be ovals, they really are supposed to be semicircles, just poorly drawn. So what if I took a semicircle and I added it to another semicircle? What would I get? I would get a circle, right? So let's just find the area of the circle of the two put together. All right, so that's going to be 1/2, or sorry, not 1/2. It's going to be pi r squared. So the area of the circle is pi r squared, but where r is what? R equals, So this is the diameter, right? That equals 70. So r equals 1/2 of 70, which is 35. All right, so that means A equals pi times 35 squared. So that is 3,846.5. And what's the unit on both of these? Well, it's given in meters. These are areas, so that's meter squared, and this is meter squared. So the total area is the area of the rectangle plus the area of the two semicircles, which is a circle. So that is 7,000 meters squared plus 3,846.5 meters squared, and that gives me 10,846.5 square meters. And that is the area of the whole thing. All right, find the area of the shaded region, not the white portion. All right, so what I want you to notice here, what's happening, is that we have this shaded area, but then we have to take out half of a circle from that. It's like it's been bitten out. So we're going to have the rectangle is going to be, let's say area again of the rectangle like we did before, is going to be 8 times 5, which is 40 square centimeters. All right, so then the area of the semicircle, that's half of a circle. Maybe I should do it the other way so it doesn't look like a D. Let's say, go like that. Half of a circle is going to be half of pi r squared, right? It's half of a circle. So stop and think about that if you need to. So I need to figure out what r is. So let me start over there. Where r equals, 1/2 of the diameter. The diameter right here is the same as this. So it's 5, 1/2 of 5. So 1/2 of 5, which equals 2.5. All right, so our area is of the semicircle is 1/2 pi times 2.5 squared. So that is 9.8125 centimeters squared. I'm supposed to round to the tenths, but I'm going to hold on until I get to the very end. All right, so the shaded portion, shaded, is going to be the rectangle. Let me just say the area of the rectangle. Area of the rectangle minus the area of the semicircle. Half of a circle is what that picture is supposed to be. All right, so we've got 40 minus 9.8125. And that gives me 30.1875 centimeters squared. But we needed to round to the tenths. So the tenths is here. What is the 8 going to do to that? And it rounds it up to a 2. So we get 30.2 square centimeters. So the key here is that you remember to subtract the semicircle that got chopped out of there. All right, find the area of the shape. So we have two things here. I'm going to draw and erase, so you might want to watch, be looking at the video. This is a trapezoid. This is half of a circle. We're just going to add them together. All right, so we've got the area of the trapezoid is going to be, our formula was 1/2 h times little b, little side, base, plus big side. I keep saying side. It's really a base, so not the side, it's the base. So big base. All right, so 1/2 times 15 times 10 plus 8. So remember to do the 10 plus 8 first. That's 18 times 15 divided by 2. And that's going to give you 135. What's the unit? Well, these are meters, so the area will be meters squared. All right, so the area of the semicircle, I just really can't draw a semicircle, but anyway, it looks like that. Semicircle is going to be half of a circle, pi r squared, half of the area of a circle. So we have pi, or 1/2 times 3.14, which is pi, times r. So what is r? This is d. So r is 1/2 of the diameter, which is 5. Okay, so that's where the 5 goes, right there. All right, so we get 1/2 times 3.14 times 5. Oh, what did I forget to do? The 5 needs to be squared. So times 25. And that gives me 39.25 square meters. It doesn't say anything about rounding, so I'm just going to leave all of that. All right, so now I get the total area is the area of the trapezoid plus the area of the semicircle. And that gives me 135 square meters plus 39.25 square meters, which is 174.25 square meters. So don't let these throw you. Take them apart into shapes that you have formulas for. All right, last one. You will see a problem like this in some of the homework. Given a circle inscribed in a square, if the sides of the square are 16, so I'm going to label this 16 on every side, right? It's a square. Find the following with the final answer rounded to a whole number. So you don't want to round until you get to the final answer. All right, what is the area of the square? So area of the square is the side squared, which is 16 squared, which is 256. What's the unit on that? It says they're centimeters, so let's write centimeters here. At least on a couple of, well, I'll just do it on, I'll be thorough. How's that? All right. So we got centimeters squared. Okay, so now the next question is, what is the area of the circle? Well, we need to know the radius. So what do you think the radius is? If it touches, inscribe means it touches. So if I go across there, that means that's half of 16, because the diameter would go all the way across and it would be 16. So the radius equals 8. So the area of the circle is pi r squared, which is 3.14 times 8 squared. And that gives us 200.96. What are the units? It's an area, centimeters squared. So it says to round to the whole number. We're going to do that at the end. So now, this is scaffolded to get us to this final question. And you may not be always asked the first two questions. You may have to figure out that the gray portion would be calculated by finding the square and then subtracting the circle. So the area of the gray portion is going to be the area of the square minus the area of the circle. And that's 256 centimeters squared minus 200.96 centimeters squared. And that is going to give us 55.04 centimeters squared, which rounds to, they want us to go to the whole number. So that is 55 square centimeters. So that's the little gray portion around the circle inside the square. 55 square centimeters. All right. Thank you for watching.